Hey Geometry, I hope that you're having a great time at home, avoiding getting sick, and this is going to be my attempt to see if we can still do class. So welcome to Inspiring Math with, without being in the classroom. So we are going to jump into 7.6. So if you could get your interactive notebook, if you need to pause the video and go get it, go ahead and do that right now. But you'll need to get your interactive notebook. We are going to start section 7.6, circles, sectors, and segments. So you'll need to go ahead and label your table, well, go ahead and update your table of contents and label the top of your page, okay? 7.6, and you'll have to bear with my writing on a tablet, okay? Okay. Again, go ahead and pause this at any point you need and try to follow along. So area of circles is a little bit of review, actually, from what we were doing for Pi Day, conveniently. So let's go ahead and take a look at a circle. Again, bear with my lack of ability to draw here. So, all right. If we are given some circle, we know that its radius starts at its center point and touches any end. Okay, the radius is from the center to any point around the circle. And the diameter goes through the center from one end to the other. So this is what Radius found when he was finding the number of pi. He measured the diameter around all the different types of circles. He found on the cheese, he found it on the basket, on the onion, on the wheels, and then finally in circumference when he was circle before he turned back into human, okay? So that's the distance all the way across. So as we noted before, some of the formulas that we put on our worksheet that we'll collect when you turn them in, hopefully Friday this week, if you guys can come drop those off, if not when you come back. So the circumference, we had the formula for. We also had the formula for the area, and we had the formula for the diameter in relation to the radius. See if you can remember any of those. Circumference is equal to, do you remember? 2 pi times its radius. Okay, or it could also be equal to the diameter times pi. Because if you have 2 pi here, and you have, I guess you have 2r here. The 2 and the r is the same as this diameter right here. Okay, so let's put that down here as well. The diameter is going to be equal to twice of my radius. And if you recall that our area's formula was pi times the radius, and that radius is squared. Remember to use the order of operations. You need to be sure that you square your radius before you multiply it by pi. You could also write it out as pi times the radius if you're putting it into your calculator. That will be a quicker way to do it. Okay, remember that pi is approximately, it's not equal to, the number goes on forever and ever and ever. It's an irrational number. That's why it's not 1/7. 1/7 in our story on Friday was the amount Radius found pi to be approximated to. However, we know that 1/7 is actually a rational number if it can be represented in a fraction. So that is not actually pi. It is close, though. So we are just going to use 3.14 for all of our purposes. If you have a pi button on your calculator, you're welcome to use that. You'll have a more exact answer. So when I get answers for this section, I will accept a number of answers that are close enough, right? So if you use 3.14, you'll be a little less accurate than someone who had the pi button on their calculator, but both answers will be right, okay? Okay, let's do an example number 1. Go ahead and write this down in your interactive notebook as example 1. We are given a circle whose diameter is 10, and we are looking for the circumference. Now we want to have the circumference in both exact form and approximation, and I'll explain what those mean as we do our example. So what is our diameter? Well, the diameter goes all the way across through the center, making sure that is 10 meters. So in order to find our circumference, we've got to go back and think about what are our formulas. So, well, in order to find the circumference, I either need pi or I need the diameter. And I'm given the diameter this time, so I'm going to multiply the diameter by pi, and that will be equal to my circumference. So let's go ahead and do that. The circumference will be equal to the diameter times pi. I'm using that dot for multiplication. Well, let's just do substitution. I know that the diameter is 10, so I'm going to use 10 and multiply that by pi, and that will be equal to my circumference. I can pretend that pi is a variable. It's not really a variable, but for my exact form, I want to say that the circumference is equal to 10 pi. Because pi goes on forever and ever and ever, we can't give its exact form without using that Greek letter of the alphabet that represents that irrational number as pi. Okay, so this here is the answer for the exact form. That's all you have to do. Now, if we are going to approximate it, this is when we will go ahead and put in some numbers. So the circumference is still equal to the diameter times pi. However, what we talked about before is that we will use 3.14 as pi. Okay, and when you multiply anything by 10, you can move its decimal place, the number of zeros you have, which is one decimal place to the right because we're making it larger for multiplying by 10. So we'll move it one place over. So our circumference in an approximation, I guess I should do this in a different color here, would be 31.4. Remember to say meters. I suppose we need meters up here also. We have to have our units, and because the circumference is the distance around, we aren't going to square this. We're just going to leave it as meters. Okay, what if we did need to find the area? Let's go ahead and find the area also. If we're going to find the area, I'm given my formula, pi r squared. In this case, I do need the radius. I don't have it in terms of a diameter, so I'm missing that piece of information. Think back to what we talked about on Friday and what you recall from other years and then earlier, that our radius is half of the diameter. Okay, any radius that goes all the way around the circle, from this point here, it could be over here, it could be here, any point on that circle. If you were to have one of the radius and you continue the radius across all the way, it would be your diameter. So twice the radius is the diameter. Okay, so let's say we need to find my radius, and that's just the diameter cut in half. So in this case, it would be 5 meters. So let's do some substitution for our formula. We're going to use pi, and then instead of my diameter, I'm going to be able to use my radius. Remember to square it before you multiply by pi so that you're following the order of operations, which say to do exponents before multiplication. So in exact form, again, we're going to do both of these, exact form and approximation. Okay, so exact form, I'm going to take and square, let's see if I can do this way. Take and square my 5. 5 times 5, remember it's not 5 times 2, it's 5 times 5. 5 times itself gives me 25. So the approximate answer would use 3.14, and we're doing exact form. So we want to say that the area is just 25 pi. Now remember, we need our units, meters, and it's squared this time because it's area. So that's exact form. Okay, well, we need to also do the approximation for our area, so we'll do the same exact thing, except we will use 3.14 this time. Okay, so let's do pi times radius squared. I'm just repeating the formula. Now we'll substitute. Instead of pi, we'll use 3.14, and instead of my radius, I can use 5. Since I figured that out, I still need to square it first. That's why I'm using parentheses. That's not really necessary. It's a little redundant with the dot and parentheses. Okay, so 3.14 times 25. Order of operations is crucial here, okay? And that's going to come out to approximately, if you plug that into your calculator or do it by hand, 78.5, and careful, you need to have your units squared for area. Circumference is just meters, and area is meters squared. Okay, example 2. Go ahead and put this in your interactive notebook as example 2. I have listed over here the formulas just to keep them in front of you. You should have these somewhere. You don't need to write those again right now, but that's just for our reference point, okay? Well, we know how to do the area. We found the circumference when we were given a diameter. Could do the same thing if you were just given a radius by cutting it in half, right? Sometimes our book's going to ask us, or you're not going to have the piece of information that isn't as simple. What if we are given the area and we have to find our radius? Well, could we work backwards? Could we be given the area and need to find the diameter even? That's going to require us to use more than one of these formulas. Okay, so let's do an example like that. I'm given that my area is 36 pi. Okay, now I'm going to be using exact values here so that we don't need to worry about all our crazy decimals. If you were to give an approximation, again, multiply by 3.14. So right now, we are given that our area is 36 pi. Well, what if I was asking for the diameter of this circle? What is the diameter of this circle? Well, we know it's all the way across, and we know its area, so that should be enough information. We're going to use the area in order to solve for my radius. Once I have the radius, we know we can double it in order to get the diameter. So there's 2 steps to this. Our first step is going to be to plug in to our formula the information that we have. So here's our formula. I'm looking for for a radius. I know what pi is. We'll leave pi as a number. So my area is actually 36 pi. I could plug that in on this side in place of area. Substitution, okay? So let's see. If I have a pi on both sides here, I have a pi by 36 and I have a pi on this side, that's going to really cancel each other. Essentially what's happening is I'm dividing both sides by pi, which means those are both going to cancel. So I'm left with 36 equals r squared. This is asking what number times itself gives me 36. You probably already figured this out in your head, but in case you didn't, or in case we have a number that's not a perfect square, I want you to see what we need to do next. We need to unsquare that, or take the square root. When you have the square root of some number and you square it, the square and the square root cancel, and you're left with just what's under the radical. So we will be left with the radius equals, and again we're talking about plus or minus anytime. For our purposes, if it's distance, it's some length for a circle. You have to be able to measure it, so we can eliminate our negative value. It's never going to be negative for distance, okay? So our radius has to be 6. Okay, great, radius is 6. Am I done? No, I'm not done. Now remember, in this case I don't have a unit, so it could just say 6 units. It's not given to me. Well, I'm asking for the diameter. I know I just have to square this, so in this case, times 2. The diameter would be the radius times 2, or 12 units. Okay, this is not really an example. We'll get to example 3. This is our next finding of area. Okay, so this is where our homework will start for Wednesday. So if you want to stop the video here, you can. This is going to be what you need to do for Wednesday. Okay? Tuesday is the area of a circle. Wednesday's homework and activity work, I guess, for the time you're at home will be about finding the area of a sector. So you may either continue to watch and work on Wednesday's work, or you can pause the video here and pick up again for Wednesday. But we are going to cover the area of a sector now. Area of a sector. Well, what is a sector? We need to know that before we even determine how to find its area. Well, this sector is essentially how big is your piece of pizza. If you have a circle, I'm going to be taking a certain section of it and finding the area. We found the area of the entire circle all the way around. Well, now we're just finding the area of a section. Sector comes from section of this circle. So if you were to cut it into pieces, you often in elementary school talked about fractions with circles and how many pieces of pizza go around, how many slices do you have, but you never really talked about how to find the area of each one. So we're going to do that today. How many degrees go all the way around a circle? Well, we remember there should be 360 degrees all the way around a circle. We talked about that a little bit on Friday. So if you go all the way around a circle, it fills up the whole circle, right? So really the area is all 360 degrees for the whole circle, pi r squared. Except we don't want that right now. We just want a section of it, this green area that I'm coloring in there. And so it's some section of the 360 degrees that goes all the way around. So our formula is going to come from that. Okay, our formula, when we write it out, is going to be the area of a sector, and I'm going to subscript it this way, will be theta, and we're not so familiar with theta. I'll describe that in a minute. It's a Greek letter of the alphabet. I usually just draw a circle and then come around a little bit further and draw a line through it. Again, it looks kind of funny with me writing on an iPad, so just bear with it being not so clear. And divided by 360, that's the degrees around a full circle, times pi times its radius squared. So what we're going to look at here is this section is how much is this sector, what fraction of the circle is the sector. Here's what we represent, would represent the area of the entire circle. When we multiply it by a fraction, it's going to be less than the entire area, right? It's just less than, it's a section. If this is a fourth of it, we'll have a fourth here. If this is half of the circle, we'd have half the circle. If it's an eighth of the circle, 1/8. But we don't know what fraction of the circle is. We're going to be given some theta, which represents the number of degrees in that circle. Theta is a variable that we are going to use, and it will be given. Sometimes we'll say that it's 84 degrees around. Well then, if we know that theta is equal to 84 degrees, that's what represents, now this obviously is not to scale, that wouldn't, maybe it's almost 84, would be the number of degrees in that sector. Okay, so you would need to come plug that in, use substitution into our formula. Okay, so I guess I already put 84. Let's just use this as an example. We need a little bit more information, and I'm going to draw a triangle inside of my sector, and you'll see why in a minute. If you see this triangle sitting inside here, the triangle is part of my sector. The sector is the whole thing though. Okay, it comes all the way out this green part to the edge. Okay, so let's name my radius as 3 centimeters, and I'm going to name this other side length of my triangle or measure it to be 4 centimeters. Okay, we're going to come back to that information for our next example. Again, go ahead and pause this at any time if I'm going too quickly. All right, well, how do we find the area of the sector? Let's use our formula. Area equals, instead of theta, I know we have 84 degrees, but it's 84 out of all 360 degrees. It's that fraction of a circle, times pi and times my radius squared. This goes back to our regular formula. Okay, remember to square that first. We get 9, not 6, right? We want to have 3 times 3. 9 times pi times my fraction here. So 9 pi and my fraction. Okay, and I'm going to leave this still in terms of pi so that this can be something that we have an exact, sorry, I'm moving color here. All right, so we'll have 9 and we'll have pi still, and I'm just going to simplify this fraction a little bit so that I can use this in a more understandable way, I guess. All right, so if I have 84 360ths, I could simplify that to 7/30ths. Something that you can divide both numbers by. I can divide both of them by 12 and get 7/30ths. Those are equivalent to each other. That's why I can substitute it. I didn't change any of the math. I just simplified it. Okay, so then we're going to multiply across up here, and 9 times 7 times pi. Remember, anything can be over 1 is going to be my numerator. Okay, so I'm going to have 63 pi 30ths. Can simplify that a little bit more by dividing both of those by 3, so I would get 21 pi 30ths for my area. Okay, and remember it was centimeters, so they are squared. Okay, and that's going to give me the area of that sector. All right, now we talked about this funny triangle inside of here, and we labeled another distance as 4. This is a triangle hidden inside of that circle, but this is what we're going to call a segment. That segment is a portion of my sector, essentially a triangle inside of my sector. So how would I find that? Well, it's some area here, and in order to find... Okay, sorry, it's choppy. This is my first ever video on this thing, so you guys are getting the rough and tough of it all. Okay, so let me see if I can explain this again now that I'm not as distracted by trying to figure out how to pause and start and all that kind of stuff. Okay, so we have this area of a triangle. We have the whole sector, which is green, and the segment is the actual... like this little blue piece out here, okay? So sector is the whole thing, right? Like a whole pizza. The triangle is like if you were to cut your crust off, and the crust itself, which it's not really all the way around, it's more of like a dome shape, okay, is my segment. So to solve for that, we need to take the area of this green sector, and we can subtract the area of this triangle. And then what would be left over would be this blue section here, okay, as my segment. So let's do an example. In this case, we would need to use our 4 distance. Let's see if I get my pointer again. Okay, this distance here to find the area of this triangle. So we could take it away from my 21 pi 30th centimeter squared. All right, so let's go to a new page so that I can give you another example that's a little bit simpler to practice this with. Okay, these segments are also what we're practicing on Thursday, so if you're still working on Wednesday's stuff, we're gonna, you can finish watching the video, or we're gonna kind of move on to what we're doing Thursday, so feel free to kind of stop it and rewatch any of the times that you need here. Okay, so segments, this is info for Thursday. All right, so here's a triangle inside of my circle. This is our example. I think we're on example 3 now, so I might be wrong about that. Okay, example 3. Assume it's example 3. We're going to find the area of this segment that I'm shading in blue, which means I need to take the area of my sector, so we just found that whole pizza slice, subtract the area of a triangle, this part here, in order to find the area of my segment. Okay, sorry, my handwriting is so bad on that. So let's say we need some information here. Let's just say that we have 5 for my radius, which if this length here is 5, what do you expect this other side length to be? Yeah, it's also a radius, so Let's make them centimeters just so we have something there. It's also 5. And then let's say that this, see if I can get some different colors here, make it a little bit more clear. All right. This side over here, let's label that as 8 centimeters. Okay, well, we have a couple things that we need to do now that we have some things labeled. First, we're going to find the area of that sector. Then we'll find the area of the triangle. And it's a lot of steps. Okay, so the area of the sector we know is, oh, sorry, I didn't tell you this either. I have it right here. This is 100 degrees inside for my theta. Sometimes it's that, remember that Greek letter that looks like that? That just means some angle measurement. Okay, so we're going to say it's 100 degrees inside there. Okay, so for my sector, I need to take the theta divided by 360, multiply by pi, and by r squared. So in this case, I'm going to have 100 over 360 times pi times 5 squared. Start with 5 squared. I'm going to get 25 times pi. I guess I'm putting these in different order. Commutative property says you can do that. And I would get 10 over 36 if I simplified that. And I can simplify that a little bit further. Right? I'm crossing those zeros out. I could have 5 out of 18. Okay, for sake of doing it the opposite way, I'm going to plug this into my calculator, and we're going to come out with an approximation. Okay, so I'm going to put in 25 times pi times 5/18. You can also, if you want, take and divide 5 by 18 first, and then hit enter on your calculator. Okay, where's my pi button? There we go. But it's up to you. Okay, so 25 times pi times 5/18 is going to come out to 21.8 centimeters squared for my area of my sector. Okay, so I'm going to come put this number in my formula up here. I'm just going to kind of plug it underneath so that we have a way to remember this. 21.8 centimeters squared. Okay, now I'm going to subtract the area of my triangle. Okay, I need to erase this so that I have some space and I don't have to redraw that picture here, but you can just leave yours there, of course. All right, so let's do the area of this triangle. This is what's going to be a little bit more complicated here. I'm going to redraw the triangle to the side, even though it's still the same triangle inside. What I need to recognize here is that I have a special type of triangle. If two side lengths are the same, it's isosceles. If my triangle is isosceles, I know that these other angle measurements down here have to be the same. Okay? And so that's a property that you may use in the future. I can also drop a height down and put a right triangle in, or a right angle inside of my triangle. Anytime you find the area of a triangle, you need its height, right? You need the line that goes from its base and is perpendicular and touches the height, or the top. So sometimes it's outside, right? Remember, sometimes it's outside of your actual triangle. Okay, but I don't know what that length is. I'm not given that. But what I do know about an isosceles triangle is that if you were to drop this perpendicular line, it's going to bisect this angle at the top. Okay, and if it bisects that angle, it's going to also bisect this side length. All that means is when you drop down your height, we're going to call this A. It's not an apotheme, but I'll tell you why we're naming it A. When we drop that down, it's going to cut this part on the bottom in half. So now we have this new little triangle inside here, and I'm going to make it yellow. This new yellow triangle has a right angle, which means I can use the Pythagorean theorem. So many steps for these problems, guys, I know. Hang in there. A squared plus B squared equals C squared. Okay, now I know that this bottom dimension down here got cut in half. Let me find my red again. Sorry, hang in there with me. Which means this short little piece down here is going to be 4 centimeters. and this is also 4 centimeters. I only need one of these triangles though, in order to find my height. All of this is literally just to find the height of this triangle inside of my sector to take it away from the sector in order to find the segment. All right? There are not too many of these problems to do tonight because there's a lot to do for each one. Once you find A, right here, I'm going to use the Pythagorean theorem because I need a right triangle to use the Pythagorean theorem. I have 2 sides, so I can find the third with Pythagorean theorem. Then I'll have this distance, which is the height, and I can go back to finding the area of the entire triangle. So that's kind of my roadmap here. All right. Now we put this into our interactive notebook, but we are just looking for A. If you were to follow through with some algebra, you would find that A is equal to the square root of C squared minus B squared. Again, that should be in your interactive notebook from Friday. So C is always the hypotenuse. Okay, this C is always the hypotenuse, which in this case is 5. Remember, the hypotenuse is across from the right angle. So come over here and it's 5. All right. So A is going to equal 5 squared minus, and the other distance I have is 4 squared, which is going to give me the square root of 25 minus 16, or the square root of 9, which we know to be 3. Again, it could be a negative 3, but we only want to deal with distance. All right, so now I know my height is 3 centimeters. If you recall, this is also a Pythagorean triple, a 3, 4, 5 triangle. If you memorize those Pythagorean triples, I didn't give them to you for just a bunch of numbers to look at. They are really helpful because once you have them memorized, you can skip this entire step. You would look at it and say, oh, 4 and 5. 5's the hypotenuse. I know this has to be 3. So that's the benefit of those. Okay, now I need this 8 centimeters back because now I'm finding the area of this whole triangle. And the area of a triangle is equal to 1/2 times its base times its height. The height being perpendicular, that's why we went through all of that to find 3. So 1/2 times 8 times 3 gives me 12 centimeters squared. Half times 8 is 4, times 3 is 12. Okay, now I found this to be 12 centimeters squared. I am finally ready to find my segment. I need to take 21, let's turn to blue here, okay, 21.8 and subtract 12, which gives me 9.8 centimeters squared. And that, folks, is the area of your segment, this blue section in here. All right. It helped us practice use the area of the sector. We also practiced the area of a triangle and the Pythagorean theorem. So this has kind of everything all wrapped into one. I hope that made some sense for you. Again, this is the information that you'll need to watch this video for your lesson on Monday, and then the information you'll need for homework and practice problems for Tuesday, Wednesday, and Thursday. Okay, then on Friday, you need to go into Desmos in order to work on another assignment. If you are having trouble with it, please don't stress about it. It is just for practice. I want you to do your best on it, but if it doesn't happen, that is not the end of the world. But I do want to give you a little rundown on how to get into Desmos. Again, this is information for Friday the 20th now. All right, so you'll need to go to student.desmos.com. Once you go there, it'll prompt you for a login password or information user code, and you will need to type in the following. I'm pretty sure that caps matters. I could be wrong about that. Go ahead and type this user code in, and it should prompt you to jump into our activity. You do not have to sign in using a Gmail account. You should be able to continue without signing in. There should be a button that says that. I think it's kind of down at the bottom. It's a little bit hidden. They probably want you to actually sign in. So use this code and click continue without signing in. Unless you want to create some account, that's fine as well. and I should be able to access that information. I can see every step that you've done, and give you some feedback from it when you come back, and see each part of the progress that you've made there. Again, if you are struggling with that, just go ahead and hit next. You can skip a slide. I do want you to do your best, try your best on it, but please don't feel stressed about it if it doesn't work. If it's a fun activity and you're able to get better understanding of sectors and area of circles, then that's wonderful. All right, we'll see you next week.